Okay, 712. So we're going to follow travels, and we're going to use bugs to do it, to kind of understand this concept of a limit a little better. So first off, we have the graph of 1 plus. So let's go. Let's see if I can give you an idea here. Right. So we're up 3. We got a vertical asymptote at 2. All right, we got a horizontal at 3. So we got something like this. Okay. And it says, place your finger on a point in the curve corresponding to x equals 5. Well, if that's 2, 3, 4, 5, we're talking about right here. Okay, Benny starts at this location and crawls along the curve to the right. So he crawls to the right. If he keeps moving along that curve, what value does he think he's approaching? He's approaching 3. So he's approaching 3. Does that make sense? Approaching 3. Okay, let's look at 15. Use the graph at the right to answer the questions. Benny starts at a point on the curve corresponding to x equals 6. So Benny's over here. Okay, Benny's to the right. Benny's the bug up top to the right, and he's corresponding to x equals 6. It says he moves left, so he's climbing uphill. How high, or what y value, does Benny think he will get close to? Okay, again, he's going to approach 5, that y value of 5. Now, there's a hole there, so he can't get there, but he's going to get close. Benny's sister Bertha starts on the curve corresponding to x equals -2 on the left. How high does she think she will get as she approaches 3? Right, 1. She's going to approach a y value of 1. Okay, so all of the getting closer to language in the previous problem is the idea behind the topic of limits. A limit is a prediction based on a pattern of y values. So if you look at your graph, so the one I graphed over here, as x is becoming greater and greater, f of x is getting closer to 3. The corresponding limit statement is this: the limit as x approaches infinity of f of x is 3. Okay, suppose Bertha starts at a point on the curve, so same thing, where x equals 5, and moves along the curve to the left. So she's moving this way. Okay, where does she think she will get as she gets closer to x equals 2? Infinity, right? She's going this way to infinity. Okay, so then write the limit statement. So here we go. The limit as x approaches 2, there's a plus there. What's that? We know that we're approaching positive infinity, but what is that? Okay, did you notice the plus? What do you think it means? Right? It means coming from the right. So this means from the right. Okay, that's a one-sided limit, right? What do you think it means if it's negative? Negative means it's coming from the left. Okay, so now use the graph to evaluate each of the following limits. So we're going back to the graph of Benny and Bertha, right? So we got the limit as x approaches 3 from the left of f of x. Well, that's this graph. Okay, so 3 from the left is 1. And then we have the limit as x approaches 3 from the right. Okay, and that we said was 5, right? Benny's crawling to 5. Cool. All right, so next graph. It says sketch the graph of, so what do we have here? F of x equals 2 over x minus 4 minus 1. Okay? All right, so the graph. minus 1 horizontal, 4, 1, 2, 3, 4 vertical. Something like this. Okay, now let's evaluate the limits. First one, as x approaches infinity, we're approaching -1. That would be down here, approaching this -1. Okay, the limit as x approaches 4 from the left. Sorry. Okay, 4 from the left, negative infinity. That'd be going this way, negative infinity. Okay, and then the last one here, 4 from the right, positive infinity. Okay. An important use of limits is to describe the behavior of a function. So like in behaviors. So, or if you know, in this case, right, if you look here, if you're approaching the same number and it goes negative infinity, positive infinity, you know you should have a vertical asymptote, right? You got some sort of vertical asymptote here. Okay. So let's look at these. The limit as x approaches -1 from the left does not exist, but g approaches negative infinity. Okay, so let's try to make sense of that. So we could just not even have a graph over there. We could just have like an asymptote at -1, and it could be like this. We're approaching infinity, but then there's nothing over here. Can't approach it from the left. Okay. The next one, the limit as x approaches negative infinity equals 2. That's a horizontal asymptote. Approaching 2. Okay, and then the last one here, 2 to the, that's just a point, right, or a hole. X approaches 2 from the right of h of x equals 5. So as we're approaching 2 from the right, whatever that is, we're getting to 5, whatever that is. Could be a hole, could be a point, doesn't matter. Okay. 19. Evaluate each of the following limits. So think of this as 1 over large, right? So if like 1 over a million is really, really close to 0. Okay, so looking at A here, the limit as x approaches infinity of 3 over x cubed. So as x gets really, really big, we're approaching 0. Look at B, the limit as x approaches infinity of 5x to the 4th. That's a really big number, so it's infinity. Again, the limit as x approaches infinity of -9 over x. Again, we're approaching 0. Now, this is a good one. The limit as x approaches infinity of sine of x. Well, we should know, what's the sine of x do? It looks like this. So we can't predict that one, right? We can't predict where it's at infinity because it repeats. Okay. E says, discuss with your team why the following does not have a limit. Can there be another function like this? Yeah, sure. How about cosine? Okay, and then the last one here, why are the following notations not used? Okay, negative approaching infinity from the left, approaching infinity from the right, and then negatives. You can only approach infinity or negative infinity from one direction. I can only approach infinity from left to right. I can only approach negative infinity from right to left. So there's no need for a one-sided limit in this case.